Jai Hind everyone. My name is Abhishek Gupta and I am working as an assistant professor in mechanical department of Ajay Kumar Engineering College. Today I will cover one of the topic of material science, that is composite materials. This topic comes under the fifth unit of material science subject. So what is composite materials? Composite materials are those materials which are formed by combining two different materials which are physically distinct, which are chemically inhomogeneous, and when these two materials joined to form a particular material, then that material is known as composite materials. These materials are generally formed from the two parent elements whose properties are entirely different from the composite materials. The, the properties of the parent materials are entirely different from that of the final composite materials. So coming on to the composite materials. Composite materials are engineering materials made from two or more constituent materials that remain separated and distinct while forming a single components. Any composite materials are formed by two different things. One is matrix and another is the reinforcement. So matrix are those binding materials which actually helps us to support the reinforcement. It provides actually the supports to the reinforcement. That's why matrix are also known as the binder. Then another is the reinforcement, which actually are generally embedded into the matrix, and when this reinforcement combined with the matrix, it forms the composites. Generally, reinforcements provide it actually enhances the physical and mechanical properties of the component, and these reinforcements are of various types like glass, carbon, natural fibers, etc. So the two elements must be chemically inert with respect to each other. So no interaction should occur upon heating until one of the components melts. Until and unless one component doesn't melt, then composite will not form. If one component will melt on providing some heating, then only these two different materials, that is matrix and reinforcement, combine to form the composites. An exception to this condition is a small degree of interdiffusion at the reinforcement matrix interface to increase the bonding. So there is one exception if the materials combine in diffusive manner, then only at some proportion composite would form. Otherwise, the composite will not form. So coming on to the next, can you think of any example of where composites are used? Actually, composites are used in variety of fields like aerospace industries, medical industries, transport industries. So one of the common example of the composites are it is generally used for the fabrication of the boat hulls. It is used in the aerospace industries where various aeroplane parts are generally produced with the help of composites. Like in Hindustan Aeronautics Limited, most of the parts of the aircrafts are generally produced with the help of composites, like its wings, its radar, its windows. All these parts are generally made with the help of composite materials. Then another is the automotive parts like panels, frames, dashboard, body, and repairs. These are also generally produced with the help of composite materials. Then sink, bathtub, hot tubs, swimming pools, all these things are also being composites are generally used for its fabrication. Then cement building, bridges, surfboards, snowboards, golf clubs, fishing poles, hockey sticks. These are also the components which are generally produced with the help of composites. Trees are technically composite materials like plywoods are generally used to form the composites. Electrical boxes, circuits, boards, contacts, everywhere, wherever you see, you will find one material that you can say that it is the composite material. So, coming on to the classifications, generally composite materials are classified by their matrix materials. So depending upon what type of matrix materials you are using, based upon that, there is one classifications like metal matrix composites, ceramic matrix composites, and polymer matrix composites. Suppose if you are using metal as the matrix in order to form the composites, then their classification will be called metal matrix composites. If you will use ceramic as the matrix in order to form the composites, then that type of composites are known as ceramic matrix composites. Then, if you use polymer as the matrix in order to form the composites, then that type of composites are known as polymer matrix composites. So, it is generally designated by MMC, CMC, and PMC. Sometimes polymer matrix composites are also known as organic matrix composites when we use the organic materials. So one by one we will discuss each and every one like metal matrix composites. So metal matrix composites are relatively soft and flexible, and since the reinforcement must have high strength and stiffness in case of metal matrix composites, and also since the load must be transferred from the matrix to the reinforcement matrix bond must be strong. So generally the metal matrix composites has longer fiber reinforcement. So whenever we want a higher strength and higher stiffness, then in that case generally metal matrix composites are used. Then next one is polymer matrix composites. Polymer matrix composites are those composites in which we use a polymer as the matrix. So these matrix composites, the matrix is relatively soft and flexible. One is the property. Another is that the reinforcement must have high strength and stiffness. Since the load must be transferred from matrix to the reinforcement matrix bond must be the strong. If the bond between the reinforcement and the matrix is not good, then there will be the problem in order to transfer the load from the matrix to the reinforcement. Then another type of composites are known as ceramic matrix composites. So ceramic matrix composites are those matrix in which we use generally ceramics as the binder materials in order to form the matrix composites. So matrix is relatively hard and brittle. The reinforcement must have high tensile strength to arrest crack growth. The reinforcement must be free to pull out a crack extends. So the reinforcement matrix bond must be relatively weak. Then coming next, composites is known as cermet composites, cemented composites, cemented carbide composites, which is also known as cermets. Cermet stands for it is the combination of ceramics plus metal. So cemented carbides, which is also known as cermets, is an example of regular particulate metal matrix composites, and as it is opposed to the dispersion strength metal matrix composites. So generally the metal matrix composites formed by particulate is one of the example for the cemented carbide. So actually there are three types other classification for matrix. One is the agglomerated composites, another is the particulate composites, and third is the reinforced matrix composites. So whenever we use any materials in particulate form, then the composites formed by using the material in the particle form is known as particulate matrix composites. So one of the examples for particulate matrix composites is the cemented carbide. Carbides such as tungsten carbides are used for cutting tool inserts, but it is hard, and generally it is ceramic in nature. That's why it is brittle. So if the so its cracks or chips under impact load. Whenever an impact load is acted upon that part, then there will be chances that the crack will be produced. So in order to avoid the crack, generally cobalt is used as the matrix in case of tungsten carbide. In cobalt, tungsten carbide ceramides are produced by pressing cobalt and tungsten powder into the compact, which are heated above the melting point of the cobalt. So on cooling the carbide, these particles becomes embedded in the solidified cobalt, which act as the tough matrix for the tungsten carbide particles. In addition to the strength and toughness, cobalt is also selected because it wets the carbide particles to give the strong bond. Then you can see these are the some of the graphics for the cemented carbide, and these cemented carbides are generally used as the insert for cutting the tool. You can see there is the spindle in which various cemented carbide tools are generally embedded, and the shapes, size of the cemented carbide is different for machining different components. So you can see this is the diagram for the cemented carbides. So this is the cutting tool inserts and a milling tool and the lathe tool. So there are these are the tools: milling tool, cutting tool, and the lathe tool. Then next uh, we will discuss about what is the particular metal matrix composites for electrical contacts. So electrical contacts are generally used in switches, relays, and motors, and it must be quite wear resistance upon us when it is under service. So the goal is to produce a contact that is having both a good conductor and it should have a good wear resistive property. So this can only be formed when we use any composites while performing any operation with the help of that composites. So whenever we want to use composites in electrical appliances also, we generally produce composites with the help of particular metal matrix composites, and this is generally done by using silver reinforced with tungsten particles, and this silver is a terrific conductor while the tungsten provides very good wear properties. So particular metal matrix composites uh, are generally formed by two stages. Its first, it has a low density compact with interconnected cores, is produced by pressing and firing tungsten powder. You can see that tungsten powder has been kept here, and then liquid silver is then infiltrated into the connected voids under vacuum. So liquid silvers are generally poured, and this liquid silver and this tungsten powder, upon pressing and heating at a very high temperature, combines to form the composites. You can see that these are the silver liquid, and when this is infiltrated into the voids under vacuum, you will see that the tungsten will take place of the voids, and a composite mixture will be formed, which actually provides the good electrical conductivity and wear resistance when we form these when we join these two materials in order to form the metal matrix composites. Then one is the cast metal particulate metal matrix composites. Whenever you join any two parts with the help of the casted materials like silicon, by addition of silicon carbide to the aluminum alloy in order to form the automotive connecting rods and the pistons, then this silicon carbide actually increases the hardness and strength of that connecting rod and the pistons when we add this silicon carbide into the aluminum alloy. And these silicon carbide particles are introduced at a temperature at which the alloy is in the solid plus liquid states. And this is done by compo casting. You can see the casted products has been shown here. Then another is the cast metal particulate composites further on. This is the compo casting of aluminum silicon carbide. Here partially solidified alloy is stirred to break up the dendrites. So you can see that the stirring of has been performing. Then the particles of silicon carbides are added at this temperature. So you can see that the silicon carbide particles has been added. Then in a pressure die casting machine, the solid mixtures become thixotropic to form a high density casting. So in die casting machine, you actually provide the pressure and you can see that this die, when comes under pressure with the help of the piston, it actually forms some casted product, and the casted products is known as cast metal particulate metal matrix composites. Here aluminum alloy and silicon carbide are used in order to form the metal matrix composites. Then next is the cast metal matrix composite has been shown here. This is the microstructure of cast aluminum alloy reinforced with particulate of silicon carbide. This has been magnified to around 125 times of the actual image. Then only you can able to see the microstructure of cast alloy reinforced with particulate silicon carbide. Then next we will discuss what is the rule for the mixture of two elements in order to form the composites. So for particulate composites, the rule for the mixture actually helps us to predict the density of the composites as well as the properties of the composites. Although other properties may vary depending upon how the dispersed phase is arranged, but the basic formula in order to find out the density of any composites is generally represented by rho c equal to fm rho m plus ff rho f, where rho c defines the density of the composite. This f refers to the this m and f refers to the matrix and the fiber, where uh, where m stands for matrix and f stands for fiber. So if you have to find out the uh, fiber matrix equal to 1 minus a fiber matrix. So from this diagram you can actually find out the density of the matrix and the density of the fiber. Whenever you multiply the density of the fiber with ff and density of the matrix with fm, then it will give the density of the composites, where f is actually represents the fraction of the composites. When reinforcement matrix and reinforcements will combine to form the one unity. So fiber reinforced composites are those composites in which fiber reinforced composites actually improve the strength, fatigue resistance, Young modulus, and strength to weight ratio over the constituents materials. And this is achieved by incorporating strong, stiff, yet brittle fibers into a core ductile matrix. So generally speaking, the fiber supplies the strength and stiffness, while the matrix binds the fiber together and provides a mean of transferring the load between the fibers. And this matrix also provides protection for the fibers. So the characteristics of fiber reinforced composites are that many factors must be considered when designing a fiber reinforced composites, including what is the length, what is the diameter, what are the orientations, what is the amount of the constituents, and what are their properties, and what is the bonding between these constituents. So all these factors should be considered in order to get the properties of any composites. So the method to produce the final product is also very important, and it dictates the type of properties just mentioned as well as the quality of the product produced. So characteristics of the fiber reinforced composites. First is the fiber length and the diameter. The fiber dimensions are characterized by the aspect ratio, which is represented by L by D, where L represents the length and D represents the diameter. And the strength improves when the aspect ratio is large. So there are various properties which helps us to use the composites in a variety of manner. So the strength actually improves when the aspect ratio is large. Typical fiber diameters are ranges from 10 micrometer to 150 micrometers. And whenever we use the composites, it actually helps us in various ways. Like it helps us to increase that strength to weight ratio of the composites are very high. That's why it has been used in the aerospace industries. And The fiber often fractures because of the surface imperfections. So making the diameter small reduces its surface area, which has fewer flaws. So whenever the aspect ratio is more, then it means the strength improvement will be seen in case of the composites. Where that's why long fibers are generally preferred because the ends of the fiber carry less load. Thus, the longer the fiber, fewer the ends, and higher the load carrying capacity will be the of the fiber. So you can see how the tensile strength is varying as the glass length fiber is increasing. You can see if the glass length is length of the glass fiber is more, then its tensile strength is also more. So you can see that the composite strength will be increased if the fiber length will be increased. So this is there is one case also if the fiber orientation is changing, then based upon the change of the fiber orientation also the stresses and the tensile strength of that composite is also changing. So you can see that the maximum strength is obtained when the long fibers are oriented parallel to the applied load. So if the loads are applied and the applying load is in the direction of the long fiber orientation, then the tensile strength in that case is very high. And as we go on increasing the angle, then you can see that the tensile strength goes on decreasing. So orientation of the fiber also plays an important role in order to decide that whether the strength which has been achieved in the composite is either poor or good. So you can see that the fiber orientation has been shown here. Like these are the unidirectional reinforced materials and it has zero variations. And here you will see cross piled quasi isotropic. Here zero angle is there 90, then 45, minus 45, minus 45, 45, 90, and 0. So the properties of the fiber composites can be tailored to meet different loading requirements. So depending upon the fiber orientation, you can actually change the loading conditions, and changing the loading conditions will help us to design the materials suitable for a particular product. So by using the combination of different fibers orientation, quasi-isotropic materials may be produced. So you can say it shows a unidirectional arrangement, question 5 figure A, and figure B shows the quasi-isotropic arrangement. Then you can see that it is a three-dimensional weave structure has been shown here, and this could be formed when fabrics are knitted or the weaved together. So you can see that these fabrics are getting together and then three-dimensional weave has been created in order to form the fiber oriented metal matrix composites. So different types of fibers also have various types like generally polymer matrix composites. Some commonly used fibers for polymer matrix composites are glass fiber, carbon fiber, and the aramid fibers. So glass fibers, carbon fibers, and aramid fibers are generally used in a variety of ways due to its superior properties of these composites. So the most commonly used fibers for metal matrix composites are the boron fiber and the carbon fiber, and the oxide ceramics and non-oxide ceramics. All these comes under the category of the metal matrix composites. So coming on to the glass fiber, due to the relatively inexpensive cost, glass fibers are the most commonly used reinforcements. As it is inexpensive, that's why glass fiber has the greater markets value. There are a variety of types of glass. You can see that they all are compound of the silica with variety of metal oxides. So you can see that it has like it represents for electrical, S stands for strength, and the electrical have the characteristics of very low electrical conductivity. S has strength, high strength, C chemical, high chemical durability, M modulus, high stiffness, A alkali, high alkali or soda lime glass, D dielectric, low dielectric constant. The most commonly used glass is E glass. This is the most popular because of its cost. Then fiberglass reinforced plastics also known as the fiberglass, generally used the textile grade fiberglass, and the textile glass fiber being as varying composition combinations of silicon dioxide, alumina, Al2, aluminum dioxide, then CO and MgO in powder form. So whenever we use their combination, it actually forms the textile glass fiber. And the mixture when heated to a temperature around 1300 degrees centigrade, and the dyes are generally used in order to extrude the filaments of this glass fiber, and the diameters of these filaments ranges from 9 to 17 micron. Then these filaments are then wound into a larger threads and spun onto bobbins for transportation and further processing. This glass fiber is by far the most popular means to reinforce plastic and thus enjoys a wealth of production processes, some of which are applicable to aramids and carbon fibers as well, owing to their shared fibrous quality. So, rowing is also a process where filaments are spun into larger diameter threads, and these threads are then commonly used for woven reinforcing glass fiber and mats. So glass fiber short threads stands and short 0.2 to 0.3 mm strands of glass fiber that are used to reinforce thermoplastics, most commonly for injection molding. Then coming on to the carbon fibers have gained a lot of popularity in the last 2 decades due to the price reduction. And the carbon fibers composites are approximately 5 times stronger than the 1020 grade steels, and it is also 5 times lighter. So that's why, due to this property, this carbon fibers has gained a very large popularity in comparison to the steel. Whereas when you will compare the carbon fiber to the 6061 grade aluminum, you will find that the carbon fiber composites are actually approximately 7 times stronger and 2 times stiffer than the aluminum, yet still 1.5 times lighter. In spite of having as the carbon fibers possess this much good property, that's why carbon fibers are generally plays a significant role and generally used in a variety of application where this 6061 aluminum or this 1020 steel can't be used. So initially used exclusively by the aerospace industry, they are becoming more and more common in fields such as automotive, civil infrastructure, and the paper productions. Coming on to the aramid fibers are also becoming more and more common because these aramid fibers are generally used to fabricate the aerospace components, and they have very highest level of specific strength of all the common fibers. So one of the main property is that the higher specific strength has been seen in case of aramid fibers or any composites. They are also commonly used when a degree of impact resistance is required, such as in the ballistic armors. So these aramid fibers are generally used to protect the persons from any from any gun or from any shots, or these aramid fibers are also used to produce the body of the tanks, as they have these types of fibers are generally protect the metals from atmospheric from outside attack, and the most commonly type of aramid is the Kevlar. So these are some of the aramid fibers like sailboat rope. These aramid fibers are used for fireproof clothing, for body armor, racing car tires, sailboat rope, etc. So these are the properties. These are the applications for these aramid fibers. So coming on to the end, why we should use the composites. One first is that its strength to weight ratio is very high. Then it has very lower specific gravity. Then its toughness, it actually improves the toughness of any component, whereas it also improves the stiffness of any component. And that creep, toughness, fatigue, all these properties increases in a very vast manner if we will use a single element for a particular application, If you want to get the combined effect of two material and enhances their property, then when you combine these two materials, you will get the superior quality of the composites in case of in when you compare them with their previous parent material. That's why composite materials plays a very important role due to these significant properties which we generally use. Thank you, class.